Hi and welcome back to my channel. This week's problem is about finding the radius of this smaller shaded circle. Now as you can see, we have got a pentagon inscribed inside a larger circle, and it's a regular pentagon. All the side lengths are 8 centimeters. The shaded areas that you can see are equal to the unshaded area. Can you find the radius of that smaller circle? I'm going to show you my solution to this problem in 3 seconds. So if you want to have a go at this problem yourself, pause the video now. Otherwise, I'm going to go through my solution. Okay. Right, so the first thing that I wanted to do is put these radii on. Now they're not going to have a length of r because that's the smaller circle, but these are the radii of the larger circle. Now from there, we are going to have a look at just this sector. Now what I've done here is I've split the problem up into, if I just go back quickly, 5 different sectors, okay, because in your pentagon we can make 5 sectors, so we're just going to consider one of them, and because the shaded area is equal to the unshaded area and the symmetry of those 5 equal sectors, the radius the shaded areas will still be equal to the unshaded areas, and we will still be able to get the radius from that. Okay, so we've got our 8 centimeters. What we can work out is the angle by doing a full turn. 360 divided by 5 is 72. What we can then work out is, because we've got 2 radii, we've got an isosceles triangle. So 180 take away 72 is 108. Split that in 2 is 54. So that will be both of our angles there. We can then work out the lengths at either side, so the radii, so these lengths x, by using the sine rule. So we've got x over sine 54 is equal to 8 over sine 72. Rearranging that, we get that x is 8 over sine 72 times by sine 54. That gives us x is 6.805. Now, I've put the dot 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 there because I'm going to store that number on my calculator. I don't want to get a rounding error. The next thing that I'm going to do is start working out some of these areas, the areas I can work out. Now, the areas I can work out here are the area of the sector, which is going to be 72 over 360 times pi x squared, pi r squared, but r in this question is the radius of the smaller circle, in this case the smaller sector. So pi x squared, because that's the radii we need to use. Area of the triangle is a half x squared sine 72. So that is this triangle here. Okay. What we are then going to do is we're going to work out the area of the segment by subtracting the area of the triangle from the area of the sector. That will give us an answer of 7.075 dot dot dot. Again, I'm going to store that value on the calculator. Okay, I'm going to keep it at the top for now, but yeah, I'm going to use the stored value on the calculator. From there, it's a bit tricky to think about, maybe. It was a little bit for me, had to think a little bit more about what to do next. Now, remember we are working out this length r, so the unshaded section, I can work that out by doing the area of the triangle minus a fifth, or 72 over 360, pi r squared. Okay, now we don't know the r here, but what we do know is we know also that the shaded area is the area of the segment, which we've got at the top, plus a fifth pi r squared. Okay, the shaded bit is both of those two areas added together. Now we know that the unshaded area is equal to the shaded area, so that gives us this. Area of the triangle minus a fifth pi r squared is equal to area of the segment plus a fifth pi r squared. Now we know the area of the triangle and we know the area of the segment, so we are going to substitute those in after adding a fifth pi r squared to each side, like this. So we get 2/5 pi r squared. The area of the triangle is a half x squared sine 72, which we used earlier. The area of the segment we have got just above there, 7.075 dot dot dot. They are truncated values, just to be clear, they are not rounded, plus the 2/5 pi r squared. Calculating the area of the triangle, we get this, 22.022 dot dot dot, and we are then going to subtract that 7.075 dot 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 from both sides to give us 14.946, etc. That's equal to 2/5 pi r squared. We are then going to divide by 2/5 on both sides, giving us 37.365, ... Divide by the pi, gives us 11.893, and then square root both sides, gives us an answer of 3.448 ... for r to what, two decimal places, nearly said one, is 3.45 centimeters. Now, if you were able to solve this problem and had a different solution, let me know down in the comments below. This is actually from an IGCSE past paper, believe it or not. It's one of the questions towards the end, the 2023 paper. Very nice problem, I think. Let me know what you think down below about me using IGCSE questions, problems in the same style as I normally do, problem solving, but using those IGCSE questions. Let me know down below what you think. Now, another cute dog photo. I said I'd put one up. Like if you haven't already, and please do consider subscribing to the channel. We are nearly, this channel is nearly at 1,000 subscribers, and that would be amazing to reach that milestone. Please, if you haven't already, help me get there. Thank you for watching. Have a great week, everybody, and I'll see you next Monday at 5 PM for another problem solving video. Until then, bye bye.